All right, let's dive right in. We're going to talk about something really cool today, an AI model that's basically proving you don't have to be a giant to be a genius. It's called SmolLM2. And yeah, this small AI is making some seriously huge waves.
So in the whole world of AI, you've probably heard this a million times. Bigger is better, right? For years, the race has been to build these absolutely massive AI models. The thinking was, more size just equals more power. But what if that's not the whole story? What if there's a smarter way to do things?
And this really gets to the heart of the issue. You've got these two extremes. On one side, you have the giant models. I mean, they're amazing, no doubt, but they are so expensive, they're slow, and you literally need a data center to run them. Then on the other side, you have these small, nimble models. They're cheap, they're fast, you can run them right on your phone. The big problem has always been, how do you get that small model to be as smart as the big guy?
Okay, so here's the game plan. First, we'll talk about that whole AI size problem. Then we'll meet our contender, SmolLM2. We'll get into its secret sauce, the special data diet it's on. We'll look at its 4-stage training, see how it actually performed, and then wrap up with why any of this really matters.
Right. Section 1, the AI size problem. So what is this problem really? Well, it's pretty simple. The biggest, baddest AI models out there are just inaccessible for most people. They need so much juice, so much computing power, that your average developer or researcher, forget about it. They're basically locked out. So the new holy grail became, can we create a seriously powerful AI that you don't need a supercomputer to run?
And that's where SmolLM2 steps into the ring. Think of it as this lightweight contender designed from the get-go to be small, fast, and super efficient. But, and this is the key part, it's built to punch way, way above its weight class.
And when we say small, we're not kidding. It has just 1.7 billion parameters. Now, you can think of parameters as kind of like the little knobs and switches inside an AI's brain that it uses to learn stuff. And to give you some perspective, the big guys, we're talking 100 billion, sometimes over 1 trillion parameters. So the real question is, how on earth can something with so few of those knobs be this smart?
Okay, so here's the secret. It's not about brute force. It's about working smarter, not harder. The team behind SmolLM2 went with what they call a data-centric approach. They figured out that it's not just about shoveling endless amounts of data at the model. No, what really, really matters is the quality and the kind of data you're feeding it.
And this quote from their paper just nails it. A small model, it has a limited brain size. You can't just dump the entire internet on it and cross your fingers. Every single thing it learns has to count. It needs to be super valuable, teaching it how to reason, not just memorize a bunch of random trivia. But, of course, there was a problem. The team hit a roadblock pretty fast. They went looking for top-notch public data to teach their AI things like advanced math and coding, and they came up empty. The stuff that was out there, it was either way too small or, frankly, just not very good.
So what do you do? Well, this is where it gets super interesting. Instead of just settling for junk food, they decided to become gourmet data chefs. They literally rolled up their sleeves and cooked up their own high-quality, specialized datasets from scratch. Each one was perfectly designed to teach these really important skills.
And here are the star ingredients on their menu. You've got FineMath, which is all about step-by-step mathematical reasoning. Then there's Stack-Edu, a hand-picked collection of really good educational code. And SmolTalk, which is designed to teach the AI how to follow tricky instructions. Think of each of these as a superfood for the model's brain. All right, so they've got their gourmet ingredients. But they didn't just throw everything in a blender. Nope. They created this really smart 4-stage training plan. It's like serving a 4-course meal, where each course builds on the last to create a perfectly well-rounded AI.
And this lays it out perfectly. In stage 1, they started with a ton of general web data, to build a solid foundation. Then in stage 2, they started sprinkling in some math and more code. By stage 3, they're refining it with better stuff, like that Stack-Edu dataset. And finally, stage 4, that's the dessert course. They bring out the absolute best stuff, those superfoods like FineMath, to give it that final polish.
You can really see the data diet change here. I mean, look at stage 1. It's basically 90% regular web stuff. But fast forward to stage 4. Whoa, what a difference. Web text is down to just over half, and now you've got big chunks of code and math in there, plus textbooks. That strategic shift, that's the whole secret right there.
Okay, so the big question, the moment of truth. After all this fancy data cooking and the 4-course training meal, did it actually work? How does this little 1.7 billion parameter model stack up against the competition?
Well, the results are pretty darn impressive. Take a look. On the ARC benchmark for reasoning, SmolLM2 is #1. And look at how it crushes the well-known Llama3.2 model in math and code. Now sure, that Qwen2.5 model is a monster when it comes to math and code, but for its size, SmolLM2's balanced skill set is just a massive win.
But let's zero in on that math score for a second, because this is just wild. This chart says it all. SmolLM2 gets a 31.1. Llama 3.2 gets a 7.6. That's not just better, that's over 4 times better. It's just a perfect example of how much that premium FineMath data paid off.
And believe it or not, it gets even better. After they fine-tuned it for chatting, they call this the instruct version. SmolLM2 really starts to shine. It's way better at following complicated instructions, and it even beats its competitor on the super hard math test. It's not just a one-trick pony. This thing is a genuinely great all-arounder.
So, okay, we've seen the numbers, we've seen it's impressive, but let's pull back for a second. What's the big picture here? What does a tiny, super smart, and totally open model like this really mean for, well, for all of us?
Well, for starters, it means we can have powerful AI that runs right on your phone or laptop, no cloud connection needed. That's huge. It also makes it way cheaper for developers and researchers to create new things, and it basically proves this whole new idea. Smart data can beat raw size. But maybe the biggest deal of all? The whole thing is completely open source.
And that right there is the cherry on top. The team didn't just give us the final cake. They give us the entire recipe book. All those custom datasets they cooked up, FineMath, Stack-Edu, you name it. They're all out there for anyone to use. It's a move that just pushes the whole field of AI forward, for everyone.
So that leaves us with a pretty big question to think about, doesn't it? SmolLM2 proved that what an AI eats might be more important than how big its brain is. So if smart data is the new AI superpower, what amazing breakthrough is it going to unlock for us next?